This is graphing systems of inequalities. And so let's get started with this first example. I just have two inequalities to graph here, and then we've got a question afterwards. So let's get started with the first one. I'll do this one in red. The y-intercept is 1. Put a dot up here at 1. And then the slope is 2. So we're going to go up 2 over 1, up 2 over 1, and so on. And then this is less than or equal to, so that means it's going to be a solid line. There we go. And less than means I am going to shade below. So I'm going to shade everything below this line. There we go. Okay, let's do the next one. So the next one is y is greater than negative x plus 4. So I'm going to do this one in kind of a navy colored. So we're going to go up 4. 1, 2, 3, 4. There we go. And the slope is negative 1. It means I'm going to go down 1 over 1, down 1 over 1, down 1 over 1, and so on. And so this line is going to be dotted because it's just greater than. So I'm going to just take my time and do a nice dotted line there. All right, this one now is greater than, so that means I'm going to shade everything above, which would be everything here and then over here. So the solution to this, oh shucks, I'm going to redo that real quick, sorry. My pen didn't stay down. Let's start over. I'll show you why. I'm going to show you why I want to redo it here in just a second. There we go. So the solution to this issue, to this problem, is wherever it overlaps. And so this section right here that I'm shading in blue is going to be our solution to this, not the other shaded parts, because it's not where it overlaps. It's not going to be where both answers are. So I'm just going to get rid of those other shaded parts. There we go. And that's going to be our final solution, is that blue shaded region. So the question is, are these points in the shaded region? Are they part of the solution? 0, 0 is right there. That's a nope. Negative 1, right there. Nope, that's not in the shaded part. And then 4, 6 over 4 up 6, that's right there. And yes, that is in the shaded part. And so anything in that blue shaded region is a solution to this given system. All right, let's go through a couple more examples here. Let's do some that are a little bit different. If we have y is less than negative 6 and x is greater than negative 4, let's do this one in greenish. Negative 6, so y equals is going to be a horizontal line. So we're going to go down 6, 1, 2, 3, 4, 5, 6. There's negative 6, and we are going to do a dashed line because it's not less than or equal to, just less than. And then the other one we'll do in orange, and it says x is greater than, oops, I forgot to do some shading, didn't I? So y is less than negative 6, that's going to be anything lower than that line. Okay, well, now we can get to, I got a little excited there. Now we can do x is greater than negative 4. So negative 4 would be right here. And we're going to do, actually, no, we're going to do a solid line at negative 4. And greater than, so I am going to shade everything above that. And the shaded, the final solution is going to be where they overlap. And so that's going to be this darker blue region. I'll highlight it with another color. So this region down here, that's where they overlap. So I'll get rid of the other stuff. One thing you could do if you don't want to actually shade each time is you could say, well, I know this green one is going to be shaded below. You could just kind of put some arrows there. And then the orange one is going to be shaded to the right. And then you just kind of find where they overlap, and it's that shaded region. This says give one solution to the system. So, I don't know, this point right here is the solution to the system. We could say that is over 1, 2, 3, 4, 5, 6, and then down 1, 2, 3, 4, 5, 6, 7, 8. So 6, -8. There's an unlimited number of solutions you could give to this situation. So like this point right here also works. That's -4, -8. It's on the line, but it's on the solid line. Like if I said this point right here at 0, -6, that one does not work. Even though it's on the line, it's on the dashed line, and so it's not part of the shaded region. But if it's on a solid line that's touching the shaded region, it does work. It is a solution. And so anything in the shaded part or on this solid line that is adjacent to the shaded part. Okay, a couple more here. This time it's given in standard form. So what I'm going to do is I'm going to take and solve each of these for y. So let's write this down. 8x plus 12y is less than 24. So let's start with that one. 8x plus 12y is less than 24. So I'm going to get y by itself. I'm going to subtract 8x on both sides. And I get 12y is less than -8x plus 24. I write it this way because I want it to be in mx plus b form, so I put the x first. All right. And then I'm going to divide by 12 to get y all by itself. I do not have to flip this sign here because I divided by a positive, not a negative. 8 and 12 are both divisible by 4, so I'm going to reduce that. That's going to be -2/3 x. And 24 divided by 12 is 2. So that's going to be the first equation, or the first inequality I'm going to graph. And then let's solve this one. Actually, I'll write it down. 6x minus 3y is less than or equal to -24. Let's subtract 6x from both sides. We've got -3y is less than or equal to -6x minus 24. And then I'm going to divide by -3. And I get y. This time I do have to flip the sign because I divided by a negative. So y is greater than or equal to. -6 divided by -3 is +2. And -24 divided by -3 is +8. So these are the two inequalities that we are going to graph, and then we're going to shade it. So let's do that. First one, let's do that in pink. We're going to go up 2, and then our slope is -2/3. So it's going to be up 2, left 3, up 2, left 3. We're going to keep going down 2 over 3. And this is less than, so I need to do a dashed line for this one. There we go. And then the other one, we'll do that one in, I don't know, red. That sound good? We'll go up 8. There's up 8. And our slope is 2, so down 2 over 1, down 2 over 1, down 2 over 1. All right, we've got a bunch of points. This is greater than or equal to, so I'm going to do a solid line. There we go. And then this one is greater than, so we're going to shade above. The pink one was less than, so we're going to shade below that line. And so my final shaded part is going to be where they overlap, which would be this region right here. All right. And so it says give one solution to this system. Well, just pick a random point anywhere in the shaded part. So we'll go right here. That's going to be 1, 2, 3, 4, -5 and +3. If you picked a different one, that is just fine. You just pick any point in that shaded part. Or you could pick any point on that solid red line that touches the shaded part. So like -4, 0 would also work. Or you could do like negative 3, 2. That's fine as well. But like this one here, negative 2, 4, does not work. Even though it's on the line, it is outside of the shaded part, and it doesn't touch the shaded part. All right, last one is going to kind of put them all together. We have 4 that we're going to graph. And so let's do this. Let's solve these two for y first. So 9x minus 6y is less than or equal to 36. I'm going to subtract 9x from both sides. I get negative 6y is less than or equal to 9x plus 36. Then I'm going to divide by negative 6. I get y, oops, I messed up. I divided by a negative, I have to flip that sign, so I'm going to fix that here. Y is greater than or equal to 9 divided by 6 is 3/2, and since they're both negative, they cancel out, it's positive. And then 36 divided by negative 6 is negative 6. So this is going to be my first line, or inequality I'm going to graph. Let's solve this one over here. 4x plus 8y is less than 16. Subtract 4x. I do not need to flip it because I subtracted. I didn't divide by a negative. That's okay. And then I'm going to divide by 8, and I still don't need to flip it because I divided by a positive number, not a negative. 4 divided by 8 is 1/2, so this is negative 1/2. And 16 divided by 8 is 2. All right, so we have 4 graphs or 4 lines, inequalities to graph. Let's start with the first one. Y is greater than or equal to 3/2 x minus 6. 1, 2, 3, 4, 5, 6. So there's the y-intercept on the first one. We're going to go up 3 over 2, up 3 over 2, up 3 over 2. And this is a solid line. So there's our solid line. The other one, we'll choose green for this one. We go up 2, and our slope is negative 1/2, so down 1 over 2. And that is a dotted line. I'm going to give myself a few more points to follow. And I will draw in a dotted line. I could definitely use the technology to make a dotted line, but it's just quicker to do it that way. And then the other two, x is greater than or equal to 0. That is going to be a vertical line at the y-axis. And that's a solid line because it's greater than or equal to. And then the y, we'll do with blue, y is greater than or equal to 0 is going to be a horizontal line. And it's going to be a solid line because it's greater than or equal to. Okay, so I didn't do any arrows. We should probably do that. On the first one, it's greater than. So that would be shading above. On the green one, the second one, that one was less than. So we're going to be shading below. The x is greater than or equal to 0 is going to be greater than. So that's going to be shading to the right. And then the y is greater than or equal to 0 is greater than, so we're going to be shading above. And so we have to figure out where do all of these overlap. And that would be in this little triangle. Let's see, I'll grab that one. This little triangle right here. So this is going to be our shaded part right there. That little red triangle. So this is our tiny little feasible region, we call it. So if I want to give a solution, it looks like 1, 1 would work. You could also say 0, 0, because that is touching 2 of the solid lines that make up this little feasible region. And a non-solution, well, there's lots of them. You could pick anything that is outside of that little red shaded spot. And so I'm just going to do like 5, 5. 5, 5 is right here, and that is definitely outside the shaded part. All right, so that is it for graphing systems of inequalities.